Imagine a machine the size of a commercial airliner, flying directly over some of the most heavily defended airspace on the planet, and no radar operator anywhere ever sees it coming. Not a blip, not a warning, nothing. Picture the men sitting in that airplane's cockpit, wide awake after nearly a full day in the air, crossing an ocean and an entire continent's worth of hostile airspace, knowing that the single greatest advantage keeping them alive is not any weapon mounted on the aircraft, but the simple fact that nobody below them has any idea they exist. In June 2025, 7 of these aircraft flew nonstop from a small Air Force base in Missouri, crossed an ocean, dropped some of the most powerful conventional bombs in the American arsenal on Iranian nuclear facilities buried deep underground, and then flew all the way back home, more than 36 hours in the air, without a single one of them ever being detected by the country they had just struck. That aircraft is the B-2 Spirit, and here's what should stop you cold before we even get into how it was built. At roughly $2 billion per airplane once you account for its total program cost, it may be the single most expensive machine any country has ever built to do one very specific job: disappear completely while carrying enough destructive power to end a war before the enemy even knows the war has started. If the idea of a bomber so effective that entire nations never even realize it flew over them is exactly the kind of story that keeps pulling you back to this channel, subscribe right now so the next one finds you. Tell me in the comments what you'd guess the total cost of this program actually reached, because I promise you the real number is going to sound almost fictional. A quick like also helps this reach more people who really need to see just how far stealth technology has actually come. Now, let's get into how America built an airplane specifically designed to be invisible. The desire to move through a battlefield completely unseen is about as old as warfare itself. And it is worth remembering that long before anyone had radar to defeat, armies were already obsessed with the basic idea of deception, camouflage, and surprise. But the specific technological challenge the B-2 was eventually built to solve did not really exist until the middle of the 20th century, once radar transformed from an experimental curiosity into the primary way modern militaries detected incoming aircraft. Radar works by bouncing radio waves off an object and measuring what comes back. And for decades after its introduction during the Second World War, the basic physics of that system seemed unbeatable. A large metal aircraft, shaped the way engineers had always shaped aircraft, for aerodynamic efficiency rather than radar avoidance, reflects radio waves extremely well. That reflection is exactly what shows up on an enemy radar screen as a bright, unmistakable dot. Here's the question that eventually changed everything about how bombers were designed. What if you could shape an aircraft specifically to scatter radar waves away from their source instead of bouncing them straight back? Engineers have been chasing pieces of this idea since at least the Cold War's earliest decades, and Northrop, the aerospace company that would eventually build the B-2, actually had its own strange head start on the concept going back to the 1940s, when a designer named Jack Northrop became fascinated with flying wing aircraft, planes built without a traditional fuselage or tail, just a single continuous wing shape. Northrop had been obsessed with the flying wing concept for purely aerodynamic reasons decades before anyone connected it to radar avoidance at all, believing that eliminating a conventional fuselage and tail would reduce drag and improve fuel efficiency, an entirely different engineering motivation than the one that would eventually make the shape so valuable. Northrop's early flying wing bombers, the YB-35 and YB-49, never entered full production, largely due to stability and control problems the engineering of that era simply could not fully solve, hampered by the primitive flight control systems and computing technology available at the time, and the entire concept was shelved for decades. But the basic shape never really disappeared from Northrop's institutional memory, and when a genuinely different kind of problem arrived decades later, that old, unfinished idea turned out to be exactly the shape stealth technology needed. That different kind of problem arrived in 1981, when the United States Air Force selected Northrop to develop what was initially called the Advanced Technology Bomber, a program shrouded in a level of secrecy that was, even by Cold War standards, genuinely extreme. The strategic logic behind the program was straightforward on paper and staggeringly difficult in practice. The Soviet Union had spent decades building an increasingly sophisticated integrated air defense network. Layers of radar installations and surface-to-air missile batteries designed specifically to detect and destroy any bomber attempting to penetrate Soviet airspace. American military planners needed an aircraft capable of flying directly through that defensive network essentially unseen, delivering either nuclear or conventional weapons deep into Soviet territory without ever triggering the alarm. Solving that problem meant rethinking almost everything about how a military aircraft was traditionally built, starting with its basic shape. The B-2's flying wing design, no vertical tail fin, no traditional fuselage sticking out from the wings, was chosen specifically because sharp angles, flat vertical surfaces, and abrupt structural transitions are exactly what reflect radar waves most efficiently back toward their source. A smooth, continuous, carefully angled surface, by contrast, scatters those same radar waves outward in directions that never make it back to the receiver at all. Every curve, every seam, every panel edge on the B-2 was engineered with that single principle in mind. Radar energy hitting the aircraft needed to bounce away in some direction other than straight back where it came from. The engines presented their own separate challenge entirely, because a jet engine's spinning intake fan is, on its own, one of the most reflective radar targets an aircraft can possibly present, essentially a rotating metal dish practically begging to bounce a radar signal straight back. Engineers solved this by burying the B-2's four engines deep inside the wing structure itself, feeding them through curved, S-shaped intake ducts specifically designed so that no radar wave entering the intake could ever travel in a straight enough line to reflect directly off the spinning fan blades and return the way it came. A solution that required years of iterative design work to balance against the aircraft's actual aerodynamic and propulsion requirements, since every curve added to an intake duct also costs the engine some measure of airflow efficiency. The exhaust presented an equally serious problem, this time involving heat rather than radar, since a jet engine's exhaust plume generates enormous infrared radiation that heat-seeking missiles and infrared tracking systems can detect even when radar fails entirely. Engineers address this by mixing the hot exhaust gases with cooler surrounding air before releasing them, and by shaping the exhaust outlet specifically to spread and dilute that heat signature across a wider area rather than concentrating it into an easy, trackable point source, essentially engineering an entire propulsion system around the goal of hiding rather than the goal of maximum raw thrust alone. Layered on top of all that careful shaping came the aircraft's radar-absorbent materials, specialized coatings and structural composites applied across the entire surface of the plane, designed to actually absorb a meaningful percentage of any radar energy that did happen to strike the aircraft directly, converting that energy into a tiny, harmless amount of heat, rather than allowing it to reflect back toward the radar receiver at all. None of these individual solutions, the shape, the buried engines, the exhaust mixing, the radar-absorbent coating, would have been nearly enough on its own. It was the combination of all of them working together, layered across a single airframe, that finally produced an aircraft capable of appearing on radar as something closer to a small bird than a 200-foot-wide bomber. The program's secrecy throughout the 1980s was genuinely extraordinary, even within a military establishment already accustomed to classified aircraft development. Workers involved in various stages of the aircraft's construction were often given only limited information about the components they were actually building, a compartmentalization strategy specifically designed to ensure that no single person outside the most senior program leadership ever possessed a complete picture of the aircraft's full capabilities. The government did not publicly acknowledge the B-2's existence at all until 1988. And even then, the first public rollout, held at Northrop's Palmdale, California facility on November 22, 1988, was carefully staged specifically to reveal as little useful detail as possible about the aircraft's actual shape and capabilities, with observers and photographers positioned at angles designed to prevent clear views of the plane's underside and rear, the exact areas where it's most sensitive stealth. Engineering actually lived. Reports from that unveiling describe an audience kept at a considerable distance, with the aircraft rolled out nose first and angled specifically to obscure exactly the surfaces the Air Force most wanted to keep hidden from any foreign intelligence services who might be watching the coverage. The aircraft's first flight followed in July 1989, still years before the broader public would come to fully understand just how transformative this program actually was. And then, almost as soon as the B-2 was ready to become the centerpiece of American strategic bombing, the entire strategic landscape it had been designed for simply disappeared. The Soviet Union collapsed in 1991, And with it went the specific singular threat, a sophisticated Soviet integrated air defense network stretching across an enormous landmass that had originally justified building an aircraft this expensive and this sophisticated in the first place. Congress, facing a dramatically reduced Cold War threat and a price tag that had already ballooned into the billions, slashed the program severely. The Air Force had originally planned to acquire 132 B-2 bombers. In the end, only 21 were ever built, and that dramatic reduction in total fleet size is exactly what drove the aircraft's now infamous total program cost, since the enormous fixed research, development, and infrastructure expenses that had been calculated across an expected fleet of over 100 aircraft instead had to be divided across barely a fifth of that number. Think about what that actually means in practical terms. Every dollar spent developing the B-2's stealth shaping, its radar-absorbent materials, its flight control systems, its specialized manufacturing facilities, all of that fixed cost still had to be paid regardless of how many aircraft eventually rolled off the production line, and dividing an already enormous total across just 21 airplanes instead of over 100 is exactly what produced the aircraft's staggering reputation as one of the most expensive machines humanity has ever built, with total program cost estimates commonly cited at roughly $2 billion per aircraft, a figure so large it has become something close to a running joke among aviation writers and defense analysts, an airplane genuinely worth close to its own weight in solid gold. For nearly a decade after its introduction, the B-2 never actually flew a single combat mission, existing purely as a strategic deterrent, a weapon whose value came almost entirely from its mere existence rather than any actual use. That changed in 1999, during the Kosovo War, when B-2s flew their first combat missions as part of Operation Allied Force, launching directly from Whiteman Air Force Base in Missouri, crossing the entire Atlantic Ocean, striking targets in the former Yugoslavia, and then flying all the way back home, entire missions stretching well over 30 hours with multiple aerial refuelings along the way. That single fact reveals something genuinely remarkable about the aircraft's actual strategic value beyond its stealth capabilities alone. The B-2 did not need forward air bases anywhere near a conflict zone to strike a target on the other side of the planet. It could fly from the middle of the American heartland, execute a precision strike, and return home, demonstrating a kind of truly global reach that very few weapon systems in human history have ever genuinely possessed. That same operational pattern repeated itself across the following decades. In Afghanistan following the September 11th attacks, where B-2s flew missions stretching past 40 hours, among the longest combat sorties in the entire history of military aviation at that point, and again during the opening phases of the Iraq War in 2003, and later during the 2011 intervention in Libya. Each mission reinforced the same basic operational reality: an aircraft capable of departing American soil, striking a target anywhere on the planet, and returning home, all without needing a single foreign base, without needing to be seen, and without needing anyone on the receiving end to have any meaningful warning before the weapons actually arrived. That entire operational philosophy reached what might be its most dramatic demonstration yet in June 2025, with a mission that deserves genuine attention on its own terms, because it captures almost everything this aircraft was originally designed to accomplish, executed under conditions of real geopolitical tension rather than a training exercise. In the early hours of June 22, 2025, 7 B-2 Spirit bombers departed Whiteman Air Force Base in Missouri as part of a mission that would come to be known as Operation Midnight Hammer, flying an 18-hour eastward route across the Atlantic and Mediterranean, refueling multiple times in midair, before striking 3 critical Iranian nuclear facilities at Fordow, Natanz, and Isfahan. Pentagon officials later described the mission as having been rehearsed extensively for years beforehand, with crews training repeatedly against simulated versions of exactly the kind of hardened, deeply buried targets they would eventually face for real, a level of preparation that reflected just how seriously military planners had always understood this specific mission profile might someday become necessary. The bombers dropped 14 GBU-57 massive ordnance penetrators, 30,000-pound bunker-busting bombs specifically designed to destroy deeply buried, heavily fortified underground facilities, marking the very first combat use of that particular weapon anywhere in the world, a weapon so specialized that its entire design purpose had been to solve exactly the kind of hardened, underground target problem Fordow itself represented. Here's a detail about that mission that genuinely deserves its own moment of attention because it captures exactly the kind of layered deception the entire B-2 program had always been built around, right down to the aircraft's original 1980s design philosophy. Alongside the 7 bombers that actually flew toward Iran, additional B-2s were deliberately sent flying west, out over the Pacific toward the American base in Guam, a calculated deception effort intended to draw public and intelligence attention away from the real strike package heading in an entirely different direction across the globe. According to Pentagon officials who later briefed reporters on the operation, this decoy plan was known to only an extremely small number of people involved in planning the mission. And it worked exactly as intended, with public reporting throughout that entire day, tracking the decoy aircraft toward Guam while the actual strike force quietly crossed an ocean in the opposite direction. More than 125 additional aircraft supported the operation in total, including fighter escorts and refueling tankers, alongside a submarine that launched cruise missiles as part of the broader strike. But the B-2s themselves executed the actual penetration of Iranian airspace and the precision strikes on the underground facilities, flying in and out entirely undetected before returning to Missouri roughly 36 hours after the mission had begun, a round trip longer than most people's entire work week, spent entirely in the cockpit of a single aircraft. Consider what that mission actually demonstrated about a program that had, at various points across its history, faced serious questions about whether its enormous cost could ever be genuinely justified, questions raised repeatedly by members of Congress, government auditors, and defense analysts throughout the 1990s and 2000s who wondered aloud whether a bomber this expensive could ever prove its worth outside of a full-scale war against a peer adversary that, thankfully, never actually arrived. An aircraft originally conceived in 1981 to penetrate Soviet airspace during a conflict that never actually happened had, more than 4 decades later, executed one of the most complex, most consequential precision strikes in recent American military history against an entirely different adversary, using weapons that did not even exist when the aircraft was first designed, and doing so without a single one of the attacking bombers ever being detected by the country whose territory they had just struck. That kind of sustained relevance across radically different decades, different adversaries, and different strategic contexts is genuinely rare for any weapons system. And it says something meaningful about just how foundational the underlying stealth engineering actually turned out to be. The specific Soviet threat the B-2 was built to defeat disappeared within just a few years of the aircraft's introduction. And yet the basic physics problem the program had solved, how do you build something large enough to carry a devastating payload while remaining functionally invisible to the sensors an adversary depends on to detect it, never stopped being relevant, regardless of which nation happened to be the specific target on any given mission. Compare that staying power to almost any other major weapons system developed during the same Cold War era, aircraft and vehicles built around specific enemy capabilities that simply vanished once the Soviet Union collapsed, leaving entire programs without any clear remaining purpose. The B-2 never faced that particular fate because the problem it solved was never actually about the Soviet Union specifically. It was about the much larger, much more durable challenge of penetrating any sophisticated air defense system a determined adversary might ever build. The aircraft has continued receiving upgrades across the decades since its introduction, modernized avionics, updated computer systems, and expanded weapons compatibility that allow it to carry an increasingly diverse arsenal well beyond the nuclear payload the original Cold War-era design had been built around. Aviation analysts who have studied the aircraft's evolution describe the modern B-2 as functionally closer to an entirely new airplane wrapped inside the original 1980s airframe, a machine that has managed to remain genuinely relevant to American military strategy across roughly 4.5 decades of continuous change in global geopolitics, adversary capability, and available weapons technology, an unusually long operational lifespan for any advanced military aircraft, let alone one this specialized and this expensive. That longevity carries its own quiet lesson worth sitting with, one that reaches well beyond military aviation specifically. The B-2 was designed to solve a problem that, strictly speaking, stopped existing in its original form within a decade of the aircraft's introduction. Once the Soviet Union collapsed and the specific air defense network it had been built to defeat simply vanished. And yet the aircraft did not become obsolete alongside the threat that originally justified its staggering cost, because the underlying engineering achievement, solving the fundamental physics of radar evasion at genuinely enormous scale. Turned out to be valuable against essentially any sophisticated air defense system any future adversary might ever build, regardless of which specific nation happened to be operating it. There are only 20 aircraft of this type left flying today, following the loss of one B-2 in a 2008 crash in Guam, meaning the entire fleet remains one of the smallest, most exclusive groups of aircraft operated by any modern military, each individual bomber representing an investment large enough to rival the annual budget of some entire smaller nations, guarded around the clock, maintained in climate-controlled hangars specifically designed to protect the aircraft's sensitive radar. Absorbent coatings from the kind of ordinary weather exposure that would degrade their stealth performance over time. That scarcity, combined with the aircraft's continued operational relevance across missions its original 1980s designers could never have specifically anticipated, captures something genuinely striking about how military technology actually ages. Most weapon systems built around a single, specific Cold War threat became historical footnotes the moment that threat disappeared. The B-2 became something else entirely. A demonstration that the ability to disappear completely from an enemy's sensors is not a temporary tactical advantage tied to one particular rival, but a permanently valuable capability worth maintaining regardless of which country happens to occupy the role of adversary in any given decade. The bomber built to slip past Soviet radar in a war that never came ended up slipping past Iranian radar in a war that very much did. More than 3 decades and an entire collapsed empire later, and it is difficult to imagine a more direct demonstration of just how far ahead of its own moment this particular airplane actually was.